All right, guys, thanks for showing up. I'm going to get started now. Okay, so today's going to be quite similar to Monday and Tuesday, more object-oriented programming practice. We're going to cover encapsulation, inheritance, polymorphism, abstraction, and at the end, we're just going to review quiz 4, which was given to us over the weekend, and then I'll let you guys go. If there's any questions, you can type them in the chat box. Fellow students, if you know the answers, you can field answers to those questions as well. And if I know the answers, obviously I'll be happy to help. Okay, so let's get started. I'm going to start right now with encapsulation, which is also a form of data hiding. So I have a package called encapsulation. I'm going to make a new class. We're going to call this class prisoners. And then we're also going to need a main method for step 2. So I'm going to create a new class, include a main method, and that class we'll call it prisoners info. Okay. So with this first class, prisoners, we're going to declare some variables. Now in encapsulation, we're going to declare these variables private to start. So got to think of some variables that would apply to prisoners. So prisoner ID, private, int, prisoner ID. And then let's give these guys a name. So again, we're going to make the variable private. So private string prisoner name, prisoner name. Give them another private string variable. Let's find out what crime they committed. So we'll write prisoner offense. And we'll give it one more variable, another string variable. Private string, let's say how long are they in jail for? So the length of their sentence. Length of sentence. Okay, so with the encapsulation, we declare our variables as private. Now, in order to have access to them elsewhere, what you can do is highlight your variables, right click, I'm going to scroll down to source, and I'm going to generate getters and setters. So we click this button. I'm going to select all. Insertion point is set at last member, meaning it's going to be after the last variable that I've declared, my last data item. Click OK. And now I have get and set methods for each of my 4 variables. So with this class, this is all I needed. I've got a getter and setter for each of my private variables. Now we're going to go to the main method. Okay. And in this prisoner info tab, the main method, we want to see that we have access to those private variables. So first, I'm going to, access the prisoners tab by making one called P1, prisoners P1 equals new prisoners okay, and let's work with our setters. Let's create P1. So you go P1 dot, and you see here we have our getters on up here, and we have our setters down here. So if you go P1 dot and you type in set, you have each of these variables. So we started with prisoner ID. Double click here, and let's make it 666 prisoner ID for P1. Now P1 also has a name, so we're going to set the name, set prisoner name, and let's call her Cersei Lannister. For those of you Game of Thrones fans, you may get the reference. Definitely someone who deserves to be in jail, or worse. Okay, two more variables to cover, so we're going to go p1.set. So we have an ID, we have a name. What is her offense? What crime did she commit? Well, Cersei, if you know the series, actually committed many crimes, but chief among them would be genocide. Spoiler alert. All right, and we have one more variable to go. p1.set, and the length of her sentence. What is her sentence? So let's see, what does she deserve? I would say forever. Forever. And then some. Okay, since it's a string type, it's in quotes. Okay. Now we've set some values for P1, prisoner 1, but we also would like to have a statement print to the console. So we're going to do a system.out, CISO, control space is the shortcut. So now we have, remember, we have getters and setters. So now, if you don't mind, remember to indent. Should I indent my CISO? Oh, yeah, you're right. You're absolutely right. Okay, so let's have a statement print out for our prisoner number 1. P1 dot, yeah, I forgot about the shortcut. So we're going to get prisoner ID for P1, double click, plus, and I'm going to add a space. So we're concatenating the statement with the variable values. Plus, now we're going to go P1 dot get prisoner name, Okay. We're going to add another space. Okay. Now we're going to get another value, P1 dot get prisoner offense. We're going to add another space. And we're also going to add the length of her sentence. So that would be, for last but not least, P1 dot get length of sentence. Okay. Now I'm just going to do one more example just to hammer it down, then we'll move on from encapsulation. So we'll call this one P2. Okay, and we need to set some values for P2. We're going to set prisoner ID. We'll give this guy 111. That's his prisoner ID. Okay. Prisoner name. I'm going to go with another Game of Thrones example. Peter Baelish. Okay. And I know that's a weird spelling for Peter, but I believe that's the one, that's how they spell it in the series. Or set another value, prisoner offense. Baelish, offense, he's done a lot of things, but I'll say his offense is being a creep. And, oh, forgot to, Fahim, you were a Thrones guy? Good, good man. Key 1 to success in this course is to study hard and learn Java every day. And key number 2 is to wind down on Sundays with some Game of Thrones. All right, so I'm going to print out one more statement. We'll see if it works, and then we're going to move on from encapsulation. So I'll start this one with prisoner ID is, I'm going to add a space here. And then we're going to say plus p2.get prisoner ID plus quotes, and I'm going to start this one with a space, and then say his name is, add another space. Then we're going to go plus p2.get prisoner name. And then we're going to add another space. Actually, sorry, we don't need to add another space. Space. He is in jail for. We're going to add his offense. So it's going to be p2.get prisoner offense. And we're almost done. We're going to add another piece of quotes. Start that one off with a space. The length of his sentence is space quotes plus p2 dot get length of sentence. All right, going to hit save all and run the program. Good. So we started off with all of our variables being private, declared private, but if you notice, the getters and setters are listed as public. Therefore, when we hit the main method, we have access to them, and then we were able to set some values and print out to the console. So 666, Cersei Lannister, genocide, forever and then some. And then this is a more coherent sentence for the second value. Prisoner ID is 111. His name is Peter Baelish. He's in jail for being a creep, and the length of his sentence is null. I spelled length incorrectly, but we're going to move on because I think most of you guys have a pretty solid handle on encapsulation. Are there any questions? Doesn't look like it. I'm going to move on. I think all of you have a pretty solid handle on this first one. All right. So now we're going to move on to an inheritance. Now there's 3 types of inheritance, as we know. Single inheritance, that's where one class inherits from another. And there's multi-level inheritance, which I'm about to do an example of, where one class inherits from another, and then another class inherits from that class, which inherited from the first class. And then there's hierarchical, which, by the way, is pronounced hierarchical. It's a weird word, but that's the correct pronunciation. I know a lot of us have had a tough time with it. We're not going to do on that today, but those are the three different types. So today we're going to work with multi-level inheritance. And I think a good example, I think a lot of you are kind of nerdy like me, you might appreciate this example. So we're going to make a new class, and we'll call it Charmander. Okay, we want to give some features to this first class, so we'll give one of his fighting moves, Scratch. So I'll make a system.out and say he can scratch enemies. And I'll give him one more. I'll say Ember. If you're familiar with the video games, these are some of his early fighting moves. And we'll say he can spit out small amounts of fire to defend himself. Okay, and we don't need to get too into it. So this is the first class that I've made. Now, if you know, Charmander eventually evolves into Charmeleon. Now, Charmeleon is the evolved form of Charmander. He will still have inherited all of the moves from Charmander. Now, with inheritance, we use the extends keyword to inherit from a different class. So public class Charmeleon, and we're going to write extends Charmander. Okay, and we'll give some values for Charmeleon as well. So we'll give him a level, a skill level, and we'll call it 18. Give him some personality traits. If you've just arrived to this session, we are working on inheritance. I'm using an example from a Pokemon video game. I started with Charmander, and so I just made a basic class and gave him 2 characteristics. Now we're going to another class, and we are extending from the first class. So public class Charmeleon extends Charmander. And let's talk about his personality. He is fiery and has a hot temper. Do not fight. Okay. And we'll give him one more value. We'll say flamethrower. And if you're familiar with the game, this is one of his strong moves. So we're going to do another system.out. We'll say fire and fury, the likes of which the world has never seen before. Which, if you follow politics, is actually an exact quote from our dear president from yesterday. But that's neither here nor there. So now we have another one. We're doing multi-level inheritance. So if I left it at this would just be a singular inheritance. I'm going to add one more level to it, as those of you who are familiar with this subject matter I'm using, there is another level to this. So this one we're going to call Charizard. Okay, and this guy inherits all of the characteristics of the previous two. So we're going to say Charizard extends Charmeleon. And Charizard has the ability to fly, so we'll give him that character. So public void fly. There's system.out and say that he can fly. All right. Now we're going to want to create a main method to make sure that this works. So we're going to go back to the package. I'm going to create a new class. This one is going to be our main method. So we click here to have a main method, and we'll call it test Pokemon. All right, so over here, we want to see that it works. So we're going to go with our third level of inheritance, Charizard. Charizard equals new Charizard. There we go. Okay, and now we're going to see, sorry. Now we're going to see if we can pull from each of the pull characteristics from each of the levels, because we did use the extends keyword, so it's supposed to work. Let's find out. Okay, and as you see here, we've got objects it shows. So this one comes from Charmander. That's the first level. We have characteristics coming from Charmeleon and characteristics coming from Charizard. So I can add this. I can go and I can add Scratch. So those were the two characteristics from the first one. And then at the second level, he inherited two characteristics from our friend Charmeleon. We've got a personality characteristic, and the other one was flamethrower. And then last but not least, we did give, on the third level, we did give one characteristic to Charizard himself, and that was fly. Okay. We're going to hit save all and run the main method. Okay. So as you see here, all of the values were able to come out. So just to summarize, we created a class called Charmander. We gave it some characteristics, Scratch and Ember. Then we created another class, Charmeleon, which inherits characteristics from Charmander. We used the extends keyword, and then so we say Charmeleon extends Charmander. We gave Charmeleon some characteristics, and then at the next level, we extended Charmeleon from Charmeleon to Charizard, and we give Charizard a characteristic. In our main method, created a variable, a new Charizard, and you have access to all 3 levels of inheritance. So that was my basic example for inheritance. Is there any questions? Doesn't look like there's any questions, so I'm going to move on to the next topic. So, as a general rule, it seems as though these first 2 topics that I covered were a little bit simpler. Most people seem to think that. So, let's get rid of these items. And now, we're going to do one called polymorphism. So I'm going to create a new class, a new package. I'm going to call it, thank you, Hussein, polymorphism. Okay. Now, if you guys remember, polymorphism poly stands for many, morphism stands for shapes, many shapes, and in this, we can declare a method, but give it the same name but different versions of it. And there's two ways we can do it. One is called overloading, and one is called overriding. Now, one of them runs in runtime, and one of them runs in compile time. Can you type in the chat box which one runs in runtime? Anybody? Overriding. Fahim, great job. And another person answers override. Perfect. So, which means that overloading is the one that runs in compile time. Definitely good to know the difference. So let's get it started. I'm gonna be a little bit less creative than I was in my first 2 examples and do one similar to what was done in class. So I'm gonna make a new class from my package. So I'm gonna make a new class. I'm gonna call it math. I'm gonna go public int add. We're gonna declare variables. So we're gonna make int x and int y. Open the curly brackets. Do int total equals x plus y. And then I'm going to return the total. Okay. Now I'm going to make another one, and here's the key here. It has the same exact name, but it's going to have different values. So this one is also called add. We're going to give it values int x, int y, and int z. Okay, we're going to open our curly brackets. We'll do int total equals x plus y plus z, and we'll have this one return the total, and we'll make another one, and as is with the last one, we're going to give it the same name, but we're going to add an additional variable. So we are overloading. So we're going to go int x, int y, and this one is called int z, and I'll make a fourth one called int q. Okay, we're going to open our curly brackets. The int total will equal x plus y plus z plus q. And we're going to return total. Okay. So far I have done an example of overloading, and now I'm going to create a new class, and I'm going to call it love math. Okay, and we're going to do a little bit of inheritance here. We're going to use the extends keyword to take the characteristics away, inherit the characteristics from the previous class. And this next one is going to be a little bit different in that I'm going to be using the same variables, but I'm going to override and make the equation a little bit different. So we're going to go public int. This one is also called add. We're going to go int x, int y, int z. Sorry, int z. We're going to open our curly braces, brackets, whatever you want to call them. The total, now we're going to make it equal to, we're going to say x plus y plus z, and we're going to say minus 10. So we're using the same exact variables as we've been using, x, y, and z, but I've changed up the equation. So that would be an example of overriding. I'm going to have it return the total. And I'll do one more, and then we're gonna go to the main method and see all of this in action. So, public int. This one is also called add, like every single one we've done so far. Int x, int y, int z, int q, int w. So this one also is another example of overloading. I'm going to say the int total equals x plus y plus z plus q plus, sorry, 1 second, q plus w, semicolon to end the command, and we're going to have that one return total. Okay, now we need a main method, so we're going to go to polymorphism, make a new class. We're going to provide it with the main method by clicking this box, and let's call it main math. So if you've noticed, all of our methods have been called add, and now we're going to see here if we can pull out all of the different values. So inside of our main method, we'll make a variable called operation math. Operation equals new math, right? Because we're pulling from that original class that we named math right up here. and we'll end it with a semicolon. Okay, so let's say make an int called basic integer value called basic math equals. Now we're going to pull a value from operation which we just created. I'm going to say operation dot, and now we have a couple of different things we can choose from. Someone unmuted? Okay, never mind. Okay, so we're going to pull a value from this operation. So this, and if you see, so you see they're all called add, and it shows you where it comes from. These ones come from the math, the first class we created. So I'll start with the basic one with two values. We give it the values x equals 4, y equals 7. All right, so now we'll give it a semicolon, and we want to be able to print out the value. So CISO control space gives us a system.out, and we want it to return this integer called basic math. Basic math. All right, so that's going to do one value. Now we'll make another integer, and we're going to call it simple math equals, and again we're going to pull a value from the operation which comes from the math class, and now we're going to do the one with 3 variables. So we'll call x4 again. Line 7. Oh, absolutely, Hossein. So, okay, so we created, within our main method, we wanted to create something, we call it operation, and it's coming from math. So when we say math operation equals new math, it's coming from math. This is their first class right here, and this is where it's pulling from. After we do that, here comes line 7, which you had a question on. So we want to create an integer value because we're only working with integers right now. We're giving it a name. That name is called basic math equals. And when we press operation dot, so let me go back. Operation dot. It's going to be pulling 3 of the equations from our very first class. We call that class math. And for this first one, I did it for the first add method, which only has 2 variables, 4 and 7. And then we have to end the command with a semicolon. Was that clear? Does that make a little bit more sense? Why did I write basic math? I'm just giving this integer a name. So I could call it silly math, and then I would have it return a value called silly math. It's just, you can call it whatever you want. You're just giving a name for this integer value, and I decided to call it basic math because it's, basic math, 4 and 7. So, if you're creating your own program, you can give it its own name, as long as your syntax is correct. You can, name your integer whatever makes sense for you when you're making your project. So I decided to call mine basic math. So now, and then I made another integer, and we're calling this integer simple math. And this is pulling from the same class. So we did operation dot add, except this time we selected the second operation from the math class. So for the first one, for basic math, we selected from this one. Now we're gonna select this one. Both methods are called add, but the when we type in operation dot, we can pull from these values. So I'm going to do the second value with 3 variables, and we'll say x equals 4, y equals 7, and we'll say z equals 11. Okay, end it with a semicolon. And now what we're going to want to do is print it out. So we're going to do SYSO control space. That's the shortcut for system print out. And we're going to print out the value for simple math. So just write in here, we're going to write in simple math. And so that will correspond to this integer value, this value, operation add 4, 7, and 11. Now, there's one more value to pull from the original math class. So now we'll call it int, I'll call this one easy math, equals, and I'm doing the same thing, operation dot add, and now we can pull from that third equation. So going back here, I want to pull x plus y plus z plus q from the math class. So we do operation dot, and we're going to this third one, x, y, z, and q. And as you see here, on the side it says math because it shows that's the class that we're pulling these values from. I'm going to double click, and we'll say 4, 7, z equals 11, and we'll say q is, let's say, 22. Okay. And just like the last one, I'm going to print out my answer. So I'm going to print out easy math. All right. So far we have now been able to access all 3 of these values. But I want to do the same thing now because we have 2 values in here I'd like to see printed out. So I'm going to move down a little bit. And I'm going to say love math because we're pulling from the love math class. We'll call it LM for short, equals new love math. So this line that I'm doing right here is what's going to allow me to pull values from here with an LM keyword. So I close my, I make my parentheses, semicolon. Now I'm going to create an integer value. And like I said earlier, you can call it whatever you want. It's your project, so I'll call this one funky. And we'll say this equals LM dot. Now, as you see here, we have access to both of the love math options as well as the math options. Because remember, I made this love math class extend the math class. So over here, when I make a love math, it actually is able to pull values from love math. And because love math extends math, I'm also able to pull values from here. But I don't need to because I already did in this earlier section. So I'm going to go LM dot. And I know this was the first equation. This was the override equation, I believe, from love math. So I'm going to double click here. I'm going to assign values. I'm just going to assign the same exact values for x, y, and z. 4, 7, and 11. And I'm going to add a semicolon to end that. And now I want to print out the value. So SYSO control space system.printout. And we want to print out the one we just called funky. Now just one more, and then we're almost done with polymorphism. So I had one more, int, we'll call this one fun, equals LM dot. Now I already used this one from love math. This was the only one That remains. So I'm going to click on this one. I'll give it some values. We'll say 4, 7, 11, 22, and we'll say W equals 44. We're going to end this line with a semicolon. And then I want to do a system.printout right here. So CISO control space system.printout. And we want to print out the value for fun. Okay, so I'm going to hit save all. And we're going to run it. Okay, and let's check my math. Okay, so 11, 22, 44, 12, and 88. So these first three are just simple addition. So we did, and they all come from here: x plus y plus z, x plus y plus z plus q. And so it's just 4 plus 7, 11. So that was the correct value. 4 plus 7 plus 11, 22. That's also correct. And then 4 plus 7 plus 11 plus 22 is 44. I use those numbers on purpose. I wanted to make the math kind of easy, so I just doubled the values. Now, this was, I want to be clear, this next one was our override function. So what I did here was we used the same variables, x, y, and z, but with the equation, I added a minus 10. So x plus y plus z over here gave us 22. But remember, over here, I pulled from a function which also added the minus 10, which is why this fourth value is 12. And then over here was another simple addition, which adds up to 88. So I started with the math class. I gave it 3 methods called add. I made a class called love math and extended all the values from math. I added an override over here and another overload. And then in your main method, that's where you kind of test most things out. And it worked. So are there any questions up until this point? Okay. Thank you, thank you, Syed. So I'm used to saying Mr. Syed. All right. So we're gonna get rid of these. And now, like most of you, the one that I actually struggle with the most is abstraction. Syed, I can afterwards I can look at our class example from nested methods and we can try and make sense of it together. But as far as what I've actually practiced is mostly inheritance, encapsulation, polymorphism, and abstraction. So I'm going to do the abstraction example. Then we're going to go over our quiz number 4, and then I'll circle back to it. I'll circle back to it and see if I can provide some value. If not, maybe our friend Fahim can do the job there. So with abstraction, the 3 key components in our abstraction package is we're going to have an interface, we're going to have abstract class, we're going to have class, and we're also, as always, you need to have a main method. So in class, we use an example with cars. Tonight, I'm going to do one with cell phones. So we'll make one class and we'll call it, we have an abstraction package, we're going to make a new class. We're going to give that class a name. We'll call it, we'll start with an interface. So we're going to make a new interface and let's call it mobile phone. Mobile phone. Okay, and we're gonna declare two right here. We're gonna say public void. We'll say we can call and we can text. So public void text. Okay, save all. Now we're gonna leave that alone, that interface alone for now. It'll come into play a little bit later on. So now I'm gonna make what we call an abstract class. So you go to new class. You click on this abstract box, which if you forget, you can just type it in manually. But if you remember, it saves you time. You just click right here. And I'm going to call this Razor generation, as in the Razor cell phone. We'll call it Razor generation. So we have a public abstract class Razor generation. Now, as we covered earlier, the extends keyword is what works when we're inheriting. But if you want to if you're inheriting from a class, but if you're want to take the values from an interface, you use the keyword. It's called implements. So we're going to say this implements mobile phone. Okay, so we implement from an interface. Keyword's pretty easy to remember because it's just I and I. I for implements, I for interface. So we implement from an interface. And so, okay, this class we're calling this Razor generation. So we're going to give it some values, public void games. This cell phone generation had some games. So we're going to open our curly brackets and give some type of value that will be printed out. So CISO control space gives us our system print out. And we'll open our quotes and we'll say has 3 free games installed. Okay. And we'll give it one more value. We'll say public void internet. As you remember, this Razor, if you do remember the Razor generation of cell phone, I believe could connect to the internet, but nowhere near on the level that we can with today's cell phones. But just for an example, system. All right. And we were going to say that it can connect to the internet. Okay, so now so far we have one interface called mobile phone. It's a very simple call and text with no specific values declared because I don't believe you can do that with an interface. Over here we have the abstract class which implements the interface mobile phone right here. Now I want to create another class. Sorry, excuse me 1 second, guys. I'm going to create actually a new interface. So you can have multiple interfaces within an abstraction example, depending on what the particulars of your program will be. We're going to call this one smartphone. Okay, we want to create some values, but just like here on this interface, we just we named these methods. We did not put in values like we did over here. So we're just going to declare a few. So let's say with a smartphone, we can go public void 4G, semicolon, public void social media. That's another feature in the smartphone generation. We'll call it social media, and we'll give it one more value. Public void. We'll say an app for everything, right? That is the world we live in today, and it's good that we're transitioning into tech because there's an app for everything. All right, so an app for everything. And we'll end the command with a semicolon. I'm going to hit save all. And for now, we're going to leave this interface alone. Now I want to create a new class. And so we have two interfaces in an abstract class. I want to create a new class, and that class is going to be considered a regular class, or what we call a concrete class in abstraction. So we're going to go new class, and I'm going to call this one Android. Okay. And in my Android class, I want to extend some values. So I'm going to say Android extends the razor generation. So razor generation. So if you guys noticed, we've not just in the inheritance example, but in two of the other examples, in the polymorphism and now the abstraction, we've been using inheritance a lot. So if that helps reinforce your knowledge of inheritance. So I'm going to say the public class Android extends razor generation. We're going to say that it implements smartphone. Now I've got a red line over here, and it says that there's two quick fixes available. The type Android must implement the inherited abstract method. So I'm going to click Add Unimplemented Methods, and it shows us all of the methods which we haven't implemented yet, and those are the ones that were that we declared in the interface. We didn't give any kind of values to those. So let me just clean up this code a little bit, and we'll start adding some values for these. Okay, so with a cell phone you can call. So we're going to give it some implementation. We're going to say, give it a CISO. We'll say you can call people on the go, which is probably how they advertised when cell phones first came out, as opposed to landline, which was the only thing before the cell phone. And then text will say you can send text messages. Okay, and we're going to give a value for 4G. And we will say solid internet browsing speed in most places. And two more. And over here, we'll give this a value a way to social media. Let's say it's a way to waste time, or you could stay in touch, or you could promote a business. Up to you. Okay. Public void and app for everything. So we want to give this one also value. So we'll say software starts in the imagination. If you can dream it, you can make it. Okay. Now, we don't have a main method yet, but before that, I'm just going to quickly review. So I have two interfaces. One of them is called mobile phone. I made my first interface called mobile phone. Then I made what's called an abstract class called razor generation, and I had it implement mobile phone from the interface mobile phone. And the razor generation, I gave it some values. And then I made one more interface. I called it smartphone, declared some values, but didn't, give it any sort of characteristics. So just called it 4G social media and app for anything. This one is this is what we call our concrete class, and we had it extend from our abstract class and implement our second interface, which is smartphone. And if you remember, I got the red line. I clicked and it said there were some unimplemented methods. And as we see here, those methods came from the interfaces: mobile phone, call text, smartphone, 4G, social media, and an app for everything. And over here, as you can see, these are the values that came out. So call, text, 4G, social media, and app for everything. So it told me that there were some unimplemented methods. And over here is when I was able to give some printout values. So next, I'd like to make a main method. So we're going to right click our package, go to new class, give it a main method, and we're going to, let's call this test droid. So I clicked in this box to make sure we get the main method. I hit finish. Now I have my main method. So we'll see if my abstraction example is able to work. So I'm going to say mobile phone, which is the name of my first interface. We'll call it lowercase mobile phone equals new Android. So that Android is the name of our concrete class, and we want to be able to pull the values from the concrete class. Why do we do it? Because you can't pull the values from mobile phone. We just know that we have values called call and text. But within our Android class, we actually do have values for call and text. That's why we do it that way. So now I want to summon those. So I say mobile phone dot. You see right here, I've got call and I have text down here. So I'm going to double click. I've got call. And then I want to summon text as well. So I'm going to go mobile phone dot. Now I can summon the other value, which is text. So I double click here. Now, now I have my values from my first interface. Now I want to pull from razor generation. This is our abstract class. I want to pull values from here. So I'm going to say razor generation, and we'll call it lowercase razr generation equals new, and we're going to pull it from our concrete class again, Android, parentheses, and we're going to end the line with a semicolon. Now let's see what values we can pull from here. So razor generation dot. Okay, and if you see here, we've got two values here. One of them is called games. Double click here. And I've got one more value to pull from razor generation. Okay, so now the other value was internet. Okay, and in this next section, we're going to, now we want to pull values from Android itself. So we're going to say Android, we'll call it Galaxy equals new Android. Now if I type in Galaxy dot, I should get a few of the values that I needed from Android. So one of these was 4G. I'm going to double click on 4G. And there was two more, I believe. So Galaxy dot an app for everything. This also comes from Android. And we're going to say Galaxy dot social media, I believe it was. Yep, social media right here. Okay, I'm going to hit save all. And I'm going to hit play. Okay, so as you can see here for call, it says you can call people on the go. Text, you can send text messages. For games, it says, if you remember, I declared it has 3 free games installed. Internet, can connect to the internet. 4G, solid internet browsing speed. An app for everything. Software starts in the imagination. You can dream it, you can make it. And the last value I said social media, and that was, that's a sentence that I declared for social media. So so far we've got an example of the 4 methods of object-oriented programming. Are there any questions? I might have a tough time fielding questions on abstraction, but I'll certainly give it a go. Is there any questions so far? Any questions at all? Or otherwise, I'm gonna just give a 5-minute break, and then we're gonna do a quiz review, and we can wrap up for tonight. So it doesn't look like you guys have any questions. Well, I asked them a couple times. They didn't say anything. So, guys, I'm gonna declare a 5-minute break right now. Let's say. All right, guys, 5-minute break. We'll be back at 8:50 p.m. for review of quiz 4. Any questions? You can type them in the chat box, and I'll do my best to field those questions after the break. So I'll see you guys in 5 minutes, all right? All right. So it is now 8:50 p.m. So guys, we're close to the end. I just want to do a quick review of quiz 4. I'm going to go over my answers that I provided, which all but one were correct, and I'll field the one incorrect answer to the rest of you guys, and then we'll be done. If you could please just offer any critiques or suggestions for my teaching style, because while I'm doing this, I'm not sure how it comes off on your end. And I want to make sure that I can offer the best uh, teaching that you guys can get some value out of. I want all of us to succeed. Josephine says, for retention purposes, what technique do you have when you build your program? Um, so for how do I remember how to do it? Honestly, it's repetition, and a lot more repetition after that. Uh, I take a lot of value from Fahim's videos, so I uh, don't worry, Josephine. We're all kind of I'm in the same boat to a degree. Uh, what I do is actually I start out by looking at Fahim's videos, and I've listened to some of the same videos and some of the same parts of the videos more than once. And I'm the type of person that maybe the average person needs to read something 3 times before they learn it. For me, I have to read something 7 times or watch something 7 times sometimes before I learn it. So it's just a matter of repetition. Honestly, Fahim, I'm able to actually project your videos after you upload them to YouTube to my smart TV, so it's very, very valuable for me. Um, Also, I don't really have an excuse to be bad at this stuff. I quit my job prior to signing up with people in tech. So me and anyone else who is currently unemployed, if by the end of this we have to retake the course or we can't get a job, that's our own fault. I mean, for any of you guys that work part or full time, this is a struggle to put in the time. But for me, I definitely I have to pass this. I have to get my job because A, I want to, and B, because I don't have a job. It'd be pretty kind of frankly disgraceful if uh, I finish this course and I have to retake it because there's no excuse for that. If I have to retake it, it's because I didn't put in the time. But anyway, I'm not gonna go into lecture mode as we often get at the end of classes. So I want to pull up quiz number 4. Um, all of my answers were under the category of correct, except one of them I answered it as a yes no, even though it was not a yes no question. So I am going to. Okay, so zoom in a little bit. Let's say 75%. Okay. So this was quiz 4 from this weekend. So what is abstraction? I said in Java, abstraction is used to hide particular details of an object. This leaves only the details that are relevant to the user. What's an interface? In Java, an interface is a collection of abstract methods. What is an abstract class? I said that a class that contains at least one abstract method and it cannot be instantiated and it relies on subclasses in order to implement the abstract methods. The next question was, what is the difference between interface and abstract class? Here's what I wrote. I said interface can only have abstract methods, while abstract class can have both abstract and non-abstract methods. Variable in the interface can be static or final, and in an abstract class it can have variables including final, non-final, static, non-static. An interface is associated with a keyword implements, while abstract classes uses the keyword extends. An abstract class can implement an interface, but an interface cannot do the same for an abstract class. And guys, while I'm going through with this, if you have a better way or a different way, or if you think what I said was actually wrong, please make yourself heard in the chat box. We all have different ways of answering these questions, but we want to make sure that we've got the accurate answers. The next question that we were asked was, can you instantiate interface and abstract class? You cannot instantiate an interface or an abstract class. It's very important. You cannot instantiate an interface or an abstract class. Okay, so then it says, can an abstract class have a constructor? The answer was yes. An abstract class definitely can have a constructor. Can there be any abstract method without an abstract class? And no, you do need an abstract class if you want to have an abstract method. So the answer is no to this question. And here is where I screwed up. I guess I was in yes/no mode at this point in the quiz. So it says, why can't we instantiate an abstract class? Does anyone have a good answer to this question? Why can't we instantiate an abstract class? All right. Okay, I'm gonna go ahead and skip that one. If you do have, an answer to it, you can type it in the chat box. If not, I'm just gonna go with, what I know for sure is correct. The next question that we were asked is, do we need to import a java.lang package? No, that's not necessary. We don't need to import the java.lang package. Next, we were asked, what is the JIT compiler? So he wanted us to kind of, think back to the Java lifecycle, all of its importance. So what I wrote is, it's a just-in-time compiler, which is more in common today than the Java interpreter. So they used to call it Java interpreter. It's part of the JVM and it executes bytecode. So what is JIT compiler? It's a just-in-time compiler and it's part of the JVM and it executes the bytecodes. Two more questions we were asked. What is JRE? That's Java Runtime Environment. It has all the necessary components to run the bytecodes. And the last question he asked us, it was about platform. And what I took that to mean was platform or operating system is the final destination for our original source code. Java, being one of the most widely used languages, can run on many platforms. Thanks to the JVM, JIT, and JRE, we are able to use the source code generated on one platform and can easily transfer it to many platforms. So that was quiz 4 in its entirety. As we've been told before, those quizzes, the questions that are on those quizzes are likely things that we're going to encounter in our interviews. So it's good to look back and review at those quizzes, make sure we can confidently answer all of our questions. So at this point, is there anyone who signed in late and wants me to review abstraction, encapsulation, inheritance, or polymorphism? Or if I went through anything too fast, I'm happy to explain any one of those 4 object-oriented programming concepts. If not, we can end this session, and I know Fahim will be introducing some new stuff to us. I know this was our 3rd day of OOP. Hopefully by now everyone has a decent handle on the subject. If there's no questions, I'm gonna you guys can call it a night, and I'll see everyone tomorrow. Thank you, Josephine. Thanks, Fahim. Josephine, nothing is intimidating. Just it's a matter of time and effort, and I'll tell you what, I'm not where I need to be. So Thursday and Friday, I have to put in a full day's work, and 7 more weeks, and we spend time on it every day. None of us should have problems in the job market. So don't be intimidated. How long have I been doing this? Um, as long as you probably. Right when day one was that Sunday after our boot camp when our first day of Selenium. That was my first day in Java. Okay, so I'm gonna go ahead and end the training now if there's no questions. Thank you, Josephine. To be honest, I honestly I am still intimidated by all of this, but you take it one day at a time, one problem at a time, and I've got 200 to 300 code lab problems to do in the next couple of days, so plenty more practice ahead for all of us, I'm sure. All right, so I'm going to thank you everyone for attending. I'm going to go ahead and end the session.